In this video, we make a jellyfish from a polyethylene terephthalate, or PET, plastic bottle in a toaster oven. Please be careful, heated plastic can be flammable. To make this, we first obtain a clean, dry PET soda bottle and remove the label and the end of the container containing the cap and any PET with the glue stuck to it. All right, and then we cut the rest of the main cylindrical part of the bottle into lengthwise strips, maybe about 1 centimeter or 2 wide. And we carefully heat the bottle in a toaster oven. Outdoors is preferred. Okay, and the toaster oven is set to about the boiling point of water, 100 degrees Celsius or 212 Fahrenheit, for a couple minutes. This is done on aluminum foil in case there's a bit of overheating that occurs by accident and there's a meltdown, but maybe you can see in the video here that the plastic is beginning to contract. When the bottle is made, the polyethylene terephthalate is stretched, and when the bottle is heated in this oven, the bottle passes up through its glass transition temperature, goes from a glassy state to a leathery state, and contracts and thickens and shortens, and you can see it curling up in the toaster oven. Glass transition temperature, by the way, is about 73 Celsius or 163 Fahrenheit. So we're above that glass transition temperature. You can see the bottle shrinking down a bit. And it gets this sort of curly appearance to those strips that we have. And so it kind of resembles tentacles. And so I'm going to pull this out of the oven right now. And you can see that it sort of resembles a little jellyfish. Okay. And since this can, again, resemble a jellyfish, but there's more to it. We can use this process to illustrate a simple measure of environmental impact of a chemical process, and that is called the environmental factor, also known as the E factor. And for the E factor, we simply take the mass of waste product produced by a process and divide by the mass of the product. And so we have a little balance here. I turn that on. And I have my waste product, my top of the bottle, and my label and my cap. And I weigh that, and it comes out to about 10 grams. All right. And I have the bottle bottom. All right. And this is the unshrunken bottle bottom. But it comes out to about 13 grams. And so if I take 10 divided by 13, I get an E factor for this of about 0.77. And, E factor can vary quite a bit from process to process. It can be less than 1. It can be up to maybe 100. Okay. But they are a simple measure that we can use to calculate the effectiveness of a process, how green a process actually is. It is pretty simplistic, though. It's simply based on the mass of the product. It doesn't say anything about the hazards associated with the product. And so there are some limitations to this process. Okay? But at the very least, it's a very simple illustration. Now, plastic jellyfish made from an empty PET bottle can be used as a reminder of the plastic waste in our oceans. All right, because real jellyfish are better to have in the oceans than plastic.